So let's have a quick look first. We are done with geomorphology. Now climatology देख लीजिए आप. Almost no questions from temperature, pressure, belts of the earth. Heat budget पे 2 question पूछा हुआ है. Atmospheric circulations are generally not difficult questions. We Hadley and Ferrell होता है. They have asked questions on stability, instability twice. So they've asked this. They have asked this one. Local winds, Sirocco वाला पूछा हुआ एक question है. Monsoons paper 1 में एक बार पूछा हुआ है. The bulk of the questions are from the second part. Jet streams, air masses, cyclones, precipitation distribution, weather climate छोड़ो, Köppen's Thornwhite ये आ जाता है, alternate year आ जाता है. Hydrological cycle is one topic not asked for quite some time. Okay, but they can, and this is an important area. Urban climate, applied climatology, response of man, and this. Okay, so I believe in terms of topics, आपके पास सब में कुछ ना कुछ notes होगा. You are not supposed to be blank at this stage. Okay, last 2-3 साल का देखो आप. What is pollution dome? Examples of impact of air mass movement on winds and weather. Rise of surface temperature and consequences. What are the changes and so on. Short-term variations in temperature, okay, and processed energy, and Earth's surface and atmosphere. The short-term variations are essentially your diurnal variations, your seasonal variations, monsoons के variations जो होते हैं, short-term, not the long one, not in terms of climate change. Factors for air mass. So air mass यहाँ पर भी है, आपका air mass यहाँ पर भी पूछा, okay. 2022 में air mass था, and 21 में भी air mass है, okay. Then major factors for precipitation variations. Precipitation यहाँ पर भी है, precipitation इधर भी है. Rise of temperature and severe consequences. So rainfall, precipitation, okay, questions related to your air masses, pollution dome, okay. Lighting, now is lighting and Halloween storm, totally, you couldn't have anticipated. इस बार 2-3 top terms होंगे. If you have heard about what is Pineapple Express, okay, what is the Omega blocking, okay, हम कुछ discuss करेंगे आज. There are a lot of talks about atmospheric rivers, okay, तो ऐसे कुछ terms होते हैं, ठीक है. Again, get back. एक सवाल पूछा है monsoons पे, okay, development of monsoon system, so paper 2 का apply करना है यहाँ पर. Again, frontogenesis, frontolysis, potential evapotranspiration, urban climate, model, Testulan model, hydrological cycle again, okay, Thevartha. So 2000 आप अगर 18 से देखते हैं, the question is this range. Last 4-5 years में, the questions are all around climate change, some new terms, cyclones, air masses, precipitation. Okay, so I think यही trend continue करना चाहिए. Okay, and maybe a bit more around climate change. A lot of talk about IPCC, lot of talk about Arctic amplification. El Nino, La Nina इस बार कुछ ज़्यादा ही news में है. Okay, in fact, one article I read yesterday, I'll get it with me. It was an article of how monsoon prediction is not easy. We do not know whether IOD will impact India or not. Proper editorial article है Times of India में, El Nino and IOD पे. So यही 4-5 सवाल होगा, because after 3 years El Nino strikes back, it will progressively become far more intensified starting from August, September onwards, and by November, December it should be a full-blown IOD, El Nino. So exam के time में El Nino news में रहेगा. Okay, so this is the range I'm thinking about, okay, in your preparation. ठीक है, तो इसी को ध्यान में रखकर I framed the 6-7 questions plus whatever practice questions we gave you. The intention of practice question is कि आपका syllabus touch हो जाना चाहिए. Okay, so let's have a quick look on this. And you have got the model answer for all of this. You would have got the booklet either online or offline. Okay, आपको शायद हम PDF दे देते हैं online आपके इसमें. So आप यही revise करके go reproduce. Questions like, okay, shift in climate patterns and rising global temperature have altered, intensified the hydrological cycle, leading to changes in the water resources. Okay. Outline the contribution of extratropical cyclones, fronts, orography, high pressure, okay, in precipitation of mid-latitude. Essentially, ये अलग-अलग words हैं, but ये actually साथ ही हैं. Cyclones and fronts together, high pressure system and orography. Okay, how they impact the. इसमें आपको examples देने पड़ेंगे. I'll discuss what we can do here. Impact of marine heat waves, because oceanography साथ में है, that's why. Marine heat waves काफी न्यूज में है. Okay, tropical, central Pacific, and whatever data you need आपके बुकलेट में है. इसमें कुछ पढ़ाने की अलग जरूरत नहीं. Know the data and the facts. The feedback loop between deforestation and droughts. Okay, you have got dry conditions. Dry conditions will create droughts. Droughts can further cause loss of forest because of forest fires. Again, droughts, and this feedback loop continues. Then air masses of North America and the influence on the region. How are air masses formed? Okay, and cyclones. Evaporation. ये वाला question previous question है. Role of evaporation in hydrological cycle. Köppen's classification. Forces governing air's movement. Okay. What are polar front? Arctic Ocean bottom relief. यही वाला सवाल आपसे पूछा नहीं है. Otherwise, they've asked Atlantic Ocean, Pacific, इन्हें पूछ चुके हैं. So Arctic पूछा नहीं है, so I want a sense of completion, that's all. Okay. Coral reefs बहुत important है. Okay, what are coral reefs? And more from the perspective of coral reef bleaching. Okay, that ocean warming, again heat waves, marine heat waves, energy. Okay, fine. And this is a state question, step instability. So what I'm suggesting is, अगर आपने ये 16 questions कर लिया, okay, with the answers, and whatever I'm discussing right now, the 6-7 of them, I think you are set for any question on climatology, other than those weird ones, एक आध पूछेगा तो नहीं पूछेगा. Okay, so this is the agenda now. Let me sum this up for all of you. Okay, what I'm discussing right now is tell you why am I teaching what am I teaching. मेरा source क्या है? मेरा source primarily है, आपने syllabus देखा. Okay, you are seeing PYQs. Bulk of the questions asked, ये 4-5 areas हैं. Air mass से पूछ रहा है, front से पूछ रहा है, climatic classification से पूछ रहा है, jet streams पूछ रहा है, and precipitation पूछ रहा है. And precipitation. To this, whatever they can ask on global climate change. इस सवाल हैं आपके. Air mass में क्या extra पढ़ाऊं बताओ? Air masses क्या हैं? Source regions क्या हैं? How they get modified? What are names of the air masses? ये तो आपका basic reading है. You should know this. Okay, temperate cyclones, fronts, for fronts. What are fronts? Type of fronts? How they interact? So I don't think I must be teaching all of this. Or climatic classification, state questions हैं. Köppen classification, Thevarthas classification. Okay, jet streams are a state question. I want to add more on precipitation and global climate change. यहाँ तक the questions are all okay, regular and conventional ones. The tricky questions हैं यहाँ पूछता है, maybe hydrological cycle they have asked okay twice now. There are some questions which are very tricky. I want कि अगर आपको एग्जाम में पूछा गया आप क्या करोगे उसका. okay, हम पढ़ा तो देंगे ठीक है, but that's in hindsight, right? I want exam condition में आप क्या करने वाले हैं. So look at the question. Discuss how, लिखो question लिखो. Discuss how warmer climates will affect precipitation and its climatological distribution, seasonality and occurrence of extreme events. Basically, how does climate change, global warming impact precipitation? यही question है. तो मैंने precipitation तोड़ दिया है. Talk about precipitation in terms of intensity, in terms of distribution, in terms of seasonality, and in terms of extreme events. तो ये तो 4 वर्ड को आपको हेल्प करने के लिए बताया मैं. Otherwise, straight question of how does climate change, global warming impact precipitation patterns of the world? So when I say it affects precipitation, इसमें बताओ क्या आएगा? 4 वर्ड है, okay? And I want to treat all of them separately. ये distribution, no problem. Seasonality in terms of seasons. Extreme events like cyclones, take cloud bursts. When I say it affects precipitation, यहाँ पर क्या आना चाहिए? what will come here? What will change are the forms of precipitation. कहीं पर sleet हो गया, कहीं glaze हो गया, कहीं snowfall हो गया. The forms will change. Okay, what else? The intensity will change. Okay, heavy rainfall, less rainfall. So how does warm climate impact precipitation? Warm climate will impact the forms of precipitation. Okay, warm climate will impact the intensity of precipitation. Then you talk about distribution. Okay, जहां पर बारिश होना चाहिए वहां पर शायद कम हो, जहां पर नहीं होना चाहिए you might have more rainfall. Okay, example of this could be El Nino, La Nina impacts, cloudbursts in the mountains, rainfall in the deserts, lot of impact of precipitation in the tropical areas. यहाँ पर बात करना है distribution की बात करना है. Where? This is what aspects change. It is where they change. What are the areas impacted? Seasonality. One common thing we are observing is because of Arctic warming, the erratic nature of the temperate cyclones has increased, and not just in winters, but also in summers. और winters में एक phenomena होता है called as blocking. I'll explain this today. There's blocking where cyclones don't move as much, खासकर anticyclones. तो seasonality का impact हो जाएगा. Yes, they can be in early summers also. Yes, ये तो कह रहे हैं early withdrawal or late onset. And extreme events, hurricanes, cyclones, cloudbursts. So आप कुछ data ले लो to help your answer. Take down some data, please. One data is that the probability of ENSO events is now more than 35% every year. The cyclones and hurricanes are 15 to 20% more intense in Arabian Sea and Bay of Bengal. Next, Arabian Sea has witnessed a 300% increase in depressions and cyclonic activities in the last 1 decade. There are as many events of cyclones in Arabian Sea as in the Bay of Bengal. Next slide down. The variability of rainfall in India, on an average, has increased by more than 10%. South Asia is one of the highest climate risk regions of the world. Okay. So that's about the first question. Now, iska structure kya hoga? How will you structure the answer? So start the answer by global warming increasing. Target is 1.52 degrees by end of the century. Increase frequency of rainfall variations. Give some of the data there. फिर आप एक map बना सकते हो if you want to make a map. What are the unusual climate events in recent years? बता सकते हैं 4-5 please across the world. Unusual climate issues. List of unusual climate events linked to precipitation or unusual precipitation events. Bomb cyclone US, Chicago, northeastern US. Lake outbursts, cloudbursts. Cloudbursts in Ladakh and Himalayas, ठीक है, fine. What else? Triple dip Nina. Fujiwara effect. Okay, fine. France में heat waves of Britain, omega blocking of Canada, Western, forest fires. So आपको ये map में, yes, absolutely. The unusual floods of Pakistan floods, and some major events of cyclones. 2-3 बता देना, including Biparjoy. We had one bad one in Australia also. Willy जो था, क्या नाम है? Forget the name. In Sydney, it impacted. Atmosphere. Now you know the answer, right? ठीक हो गया आपका? So a paragraph on what are the changes, one map on what are the important events of precipitation-based climate change. अब आप एक-एक बताओ. Number 1, global warming, climate change, and impact on precipitation. उसमें number A, impact on intensity of rainfall and impact on forms of precipitation. So unusual snowfalls, unusual hailstones, long dry seasons of Europe, of the US, of Canada, Okay. Wetter monsoons of last 3 years, the precipitation has changed. Number 2 is impact on rainfall distribution. Rainfall distribution. There are regional variations in rainfall distribution. The tropical areas have higher variability. Both swings, we have higher incidence of heavy rainfall and also higher incidences of drought conditions. Dono swings hain. Okay. We have wetter rains or wetter conditions in parts of the deserts. Saudi Arabia has had rains. Sahel belt has had unusual rains. Then batana distribution, where all. The hill areas have more frequent cloud bursts. Okay? So, ye first 2 points ek saath likhna. Rainfall and the distribution. Third is seasonality changes. Okay. And write down, this is best observed in monsoon seasons or monsoon regions. Early withdrawal of monsoons, late onset of monsoons, a prolonged effect of western disturbances beyond winters. Seasons of tropical cyclones have changed. Prolonged summer seasons in the temperate regions. I think in seasons, mein sabse impact ye hai, the transition seasons have become shorter. Okay, there are 2 transition seasons, okay? Your autumn and spring. The transition seasons have become shorter. There is intensification of winters and also intensification of summers. The 4th is climate change and occurrence of extreme events. इसमें तो अब डाल देना है proper case study of Biparjoy. With a diagram, you can draw that. You can draw a diagram of Mocha cyclone. Okay, Mocha is unusual. You don't have Mocha as early as in the month of May, June. Okay, Arabian Sea apne aap mein unusual hai. Tauqat cyclone was also there. Okay, pick up some of the names there. You can recall any name of hurricane last year wala mujhe naam yaad nahi aa raha hai. Any name of an hurricane? Hana. Pick up 1 or 2. Mujhe yaad nahi aa raha abhi immediately. Pick up 1 or 2 of those. And alag se do write about triple dip Nina and El Nino. Ye alag se likhna aap. 3 consecutive years of La Nina and a paragraph on El Nino of 2023. They're anticipating the El Nino will be far more intense this year. Okay, but kya impact hoga India mein, we do not know. That's about it. Conclusion is, okay, climate change induced challenges. Okay, we need adaptation, disaster management. Okay, deal with water stress. A national action plan on climate change. A change in rainfall will impact desertification. मैंने कुछ एक्स्ट्रा पढ़ाया नहीं आपको, just helping organize things. Yes, you can, Roshan. Yes, you can. But glacial outburst is not a phenomena of rainfall. आप ये समझ नहीं पा रहे हो. ये क्वेश्चन पूछ रहा है climate change and precipitation. Is glacial outburst because of precipitation? It's because of melting glacier and the glacier breaching the lakes or the moraine dams. आपको सब थोड़ी लिखना है यहाँ पर. You must write about climate change and impact on precipitation. Glacial outburst floods is not because of precipitation. It's because of glacial retreat, melting glaciers, and that is breaching the dams. हम बता रहे हैं निखिल, अभी करो. The examples I have given you now, you now use it. Okay, go with the discussions. You'll get all your answers. Okay, that's done. The next question is, the urban heat island effect is a critical factor for air quality management and public health in urbanized areas. The next question is, urban heat island effect is a critical factor for air quality management and public health in urbanized areas. So we all know about urban heat island. इसको लिंक करना है with urban pollution island. UPI एक नया concept है. Okay, urban pollution island. This is urban heat island. Okay. So see, all of us know that urbanization leads to urban heat island. ये पता है हमें. आप लिख लेंगे आप. मैं पूछ रहा हूं बताओ, how is it related to air quality and public health? Don't just write about urban heat island and come back. आपको relate करना है urban heat island and its impact on air quality and public health. Can you think? से मैंने आपको ये क्वेश्चन दे दिया, एग्जाम दे दिया, आप कैसे लिखोगे इसको? मुझे कॉज इफेक्ट बताओ पहले. ये आप सर, गिव मी द कॉज इफेक्ट. Urban heat island as a cause for pollution and pollution as a cause for urban heat island. पहले ये आप डिसाइड करो ना, आप लिखना क्या चाह रहे हैं. So one discussion is yes, higher pollution. We have got higher greenhouse gas emissions. We have a higher aerosols. So you'll have higher heat absorption. So urban heat island. Okay, that's one. ये एक रेशो हो गया ये वाला आपका. अब urban heat island primary cause क्या है? What is the primary cause of urban heat island? It is primarily concretization. More buildings, more surface area, more absorption of heat. Concretization is the primary reason for urban heat island. Does this cause pollution? इसको ऐसे करेंगे. Does concretization cause urban heat island and does this cause pollution? आगे pollution कैसे हुआ? Okay, fine. Listen. It operates in two ways. There are two ways. One is urban heat island. This forces a higher domestic cooling needs of energy. आप ज़्यादा AC use करोगे. Okay, and this AC results in pollution. This can result in higher emissions also. More power required, more power generation. Okay, अगर outages हैं तो diesel use होगा ज़्यादा आपका. Okay, and leads to pollution. This is more like an indirect relationship. More concretization, more urban heat island. More urban heat island का मतलब है higher needs of domestic cooling, higher needs of commercial cooling. Okay, more cooling means more emissions and therefore pollution. More cooling, more energy needs. This higher energy, use intensity. Okay, and therefore more pollution. This is one way of impact. ठीक है? तो जहां पर higher urban heat island है, तब pollution भी होता है. And this kind of becomes positive feedback loop. More warming, more emissions, more warming, again further more heat island. It kind of becomes a positive loop. और एक भी relationship है. What happens is, अब इसको आप लिख लो. I'm talking from a report here. Write down. 1, 2, 3, 4. Okay, first is higher temperatures because of urban heat island accelerate certain atmospheric chemistry cycles. They accelerate certain atmospheric chemistry cycles, leading to enhanced ground level tropospheric ozone. Ozone is formed by photooxidation of VOC, volatile organic chemicals. Oxidation of VOC in the presence of nitrogen oxides, which is more likely during urban heat dome. Next, the presence of urban heat dome, UHI, the presence of urban heat dome creates more drier conditions. This in turn releases more dust. It releases more dust. It increases aerosol proportions in the atmosphere, further enhancing both pollution and also urban heat dome effect. Urban heat dome effect. Next, urban heat dome, UHI, increases Bowen ratio, BOWEN, increases the Bowen ratio of urban environment. ये ratio क्या है? This is the sensible heat exchange divided by the latent heat exchange. What is Bowen ratio is? The sensible heat exchange divided by latent heat exchange. Okay. So if I have a land here and I've got buildings here, if I have the buildings here, okay, you'll have less moisture here. Less moisture ka matlab hai the latent heat exchange is very less. But I have got more buildings, the absorption of heat is more. The sensible exchange is more. Okay, this is called as the Bowen ratio. So Bowen ratio is the latent heat reduces why the environment is drier. Okay, so it's like whatever heat I have, rather than it being absorbed by the moisture and getting distributed, the heat now gets concentrated. Okay, continue further. This can lead to secondary consequences where there is more emissions from plastic waste in the form of biogenic hydrocarbons that adds to pollution. Biogenic hydrocarbons that adds to pollution. Basically, again, same idea. Air is very dry. Dry air है और very warm air है. तो अगर पॉलीथीन प्लास्टिक्स होंगे, इससे कुछ केमिकल्स रिलीज होते हैं. If it is moist, the release is less. Okay, something like you are kind of roasting, okay, or burning, okay, all of these plastic wastes. Okay, the dry conditions, there is some release of chemicals from the plastics and polythenes. This will increase the pollution rates. Next, further, okay. The urban areas can also witness urban forest fires or spontaneous combustion of landfills. सुना आपने? Okay, जहां पर आपने गार्बेज डंप किया वहां आग लग जाता है, वो भी तो emissions होगा ना उसका भी. They are also toxic emissions. Okay, and we have seen this in Bangalore. The Belandur Lake had a fire. Okay, because of pollutions, dry conditions will catch fire. Okay, urban heat island, more warming and spontaneous combustion. Yes, of combustion of landfills and pollutants. Okay. Add one point last में add करो. Urban heat island can have a temperature anomaly of 10 to 15 degrees centigrade above the rural and countryside temperatures. This increases peak electricity demand, it increases transportation emissions also, and thereby altering the thermal balance of urban spaces. So urban areas are not merely receptors. Urban areas are not merely receptors of climate change. They're also drivers of climate change and environmental pollution. They're also drivers of climate change and environmental pollution. Okay, this is done. Next is question number 3. Arctic amplification and consequent changes in strength and position of northern hemisphere jet stream will allow blocking events to become more frequent. Not sure aise पूछेगा, but you can always use this in discussion of climate change. Arctic amplification and the consequent changes in the strength and position of northern hemisphere jet stream will allow more blocking events to become frequent. Okay. Let's get back. Let me explain this to you. Okay. We all know the effect of the equator to poles gradient of temperature, and because of this you have the upper tropospheric westerlies, and inside those we have jet streams. So it's like this. This is that's equator, that's the poles. Equator is warm, the poles are very cold. So this is equator to pole thermal gradient ho gaya. Okay. More cold the poles are, the more strong is the PGF. Okay, we have thermal gradient, okay, between equator and the poles. Okay, this is basically difference of temperature between equator and poles, and this difference is strong when the poles are cold. Okay, so when the poles are cold, the PGF is very high, so the winds are moving fast, and because they've been moved very fast, you have the upper tropospheric westerlies. Okay, and eventually they come here and become the jet streams. Okay, you have got jet streams, the polar jet streams. Fine, all of you. Now what's happening is, this is what is polar amplification. The Arctic and the Antarctic are melting. Okay, Why is the Arctic so cold? Arctic is very cold because of one reason is that away from the equator it becomes cold because of Earth's curvature. Plus cold conditions, you have got ice, you have got snow. The snow increases albedo and therefore the pole becomes even more cold. It's like a positive loop happening. Okay, pole is cold, pole has ice and snow. The ice and snow has more albedo. The poles become even more cold. Okay, so the ice, snow, this is the cryosphere. Okay, the ice and snow here, it maintains the low temperature of the poles because of high, okay, your albedo losses. Now what happens is when the poles become warm, okay, ice is melting. Ice is melting, so the absorption, okay, of heat at the poles is increasing. That further increases the temperatures and makes it even more melting. That's what is Arctic and Antarctic amplification. I believe most of us know that. Because the poles are becoming warm, the gradient of the pressure is becoming less now. ये तो warm है, ये cold होना चाहिए, अब ये warm हो गया. Okay, so PGF is reducing. When the PGF reduces, the winds will now slow down. So the geostrophic winds are still there because of less friction. But the geostrophic winds are now slowing down. When the geostrophic winds slow down, the jet streams slow down. And the jet streams, which should have been near the subpolar areas, have now come a bit more, okay, tropicwards. It's like when I spin very fast, the jet streams can go towards the poles. But when they become slow, okay, they will now come towards tropics. Okay, so three things here. Number one, the jet streams and the Arctic circulations are slowing down and they are shifting polewards. Sorry, tropicwards. They're shifting tropicwards. Okay? Acha, now, ये jet streams हैं. The jet streams, remember, they have high pressure, low pressure systems. The jet streams will have the temperate cyclones. The high pressure, low pressure. High pressure, low pressure. Okay. Low pressure mein air is rising. High pressure mein air is sinking. Okay. Now, when the jet stream has become slow, okay, the movement of the cyclones and anticyclone also becomes very slow. पहले क्या था? A cyclone system, front system is moving very fast. पीछे एक move कर रहा है, okay, high pressure. फिर एक और पीछे आ रहा है, low pressure. एक और आ रहा है, high pressure. It goes on like this. But when the west to east, okay, jet stream is slowing down, the west to east movement of the cyclones and anticyclone also becomes slow. Okay, so a cyclone which is moving और पीछे anticyclone is slow हो जाएगा. So because slow movement, okay, we call this as blocking. So when the west to east movement of cyclone slows down because of the upper tropospheric winds slowing, because of the jet stream slowing, it's called as blocking. Achha, high pressure mein, what will you have? Adiabatic compression or will you have expansion? जब high pressure है, air is sinking, क्या होगा आपका? Adiabatic compression. Warming or cooling? Warming. So imagine, I have a high pressure, I have a low pressure. They will move like this. When moving like this, they become very slow. When they become slow, this area has a cyclone, this area has the anticyclone, यहाँ पर air is sinking. This sinking air, a warm condition, वैसे भी global warming है, air warm करके यहीं फंस गया, ये move ही नहीं. That's what's called as a blocking phenomena. This can cause serious heat waves. Okay? ये जब आराम से निकल जाता तो निकल जाता, कोई प्रॉब्लम नहीं. ये अब ये मूव ही नहीं कर रहा ठीक से. It's kind of a stationary system. The geostrophic winds are slowing down. This is related to the jet stream slowing down because the thermal gradient between the poles equator is becoming less. Because the poles are becoming warmer. This is what is also the polar vortex. You spin kar rahe polar vortex hai. Ye polar vortex now coming towards the tropics. Is it okay all of you here? So blocking phenomena is becoming more and more common. Okay. So this is the meandering winds. This is a high pressure. This is low pressure. This is high pressure. This is low pressure. Okay. In these areas, you will have cyclones, anticyclones, and so on. जब ये move नहीं कर रहा है, तो इसके नीचे क्या होने वाला है? I will have a low pressure. I will have a high pressure. I will have a low pressure. I'll have a high pressure. The low pressure ones are the temperate cyclones. समझ में आ रहा है यहाँ पर? और ये high pressure में air is sinking. High pressure में air is sinking. When air is sinking here, and this is not moving properly, the sinking air, this area can become very, very warm. Okay, this is the heat wave. Or because move नहीं कर रहा है, I call this as thermal blocking. Okay, और इस diagram में this is letter omega of Greek alphabets. It's also called as omega blocking. The shape is such that this is called as an omega blocking. It happened last year, correct? What I want is through these discussions, आप answer on impact of global warming आप और sharp लिख लेना. वो किस form में पूछेगा मुझे नहीं पता. Okay, but you know now three things. Change in precipitation आपने जाना. Second, you know about now the impact. Okay, cyclones, urban heat island. Use this for an answer on how climate change impacts the climate areas of the regions with examples. Okay, now write down. I've explained this to you. Okay, well, I say point wise. The first point is global warming has led to warming of the polar regions, Arctic and Antarctic. Number two, this has reduced equator to pole temperature gradient and therefore has slowed the upper tropospheric westerlies and the upper tropospheric jet streams. Slowed upper tropospheric jet streams and upper tropospheric westerlies. Next, this warming of the Arctic and Antarctic regions is referred to as Arctic-Antarctic amplification. Arctic-Antarctic amplification. Next, the amplification phenomena has weakened the polar vortex. So there, so I had this as the polar, this was the polar vortex. This has weakened. What has happened is the polar vortex has now shifted, tropicwards. It has shifted tropicwards. Ye old vortex, ye hai naya vortex. It has shifted, tropicwards. Right, next. This shifting of the polar vortex has three consequences. Number one is it brings the cold Arctic air to mid latitudes. It drags. पहले क्या था जब यहाँ पर था polar vortex तो सारा ठंडा हवा इसके अंदर रहता था inside this. अब जब नीचे आ गया the Arctic air is now coming tropicwards. It brings the cold Arctic air tropicwards. This can cause intense heavy snowfall in the mid latitudes. Intense heavy snowfall in the mid latitudes. यही हुआ शिकागो में हुआ है, बॉस्टन में हुआ है this year, including the bomb cyclone also. With more moisture, it can become a bomb cyclone. Heavy snowfall. That's one impact. The second impact is it brings dry conditions and droughts to mid latitudes. Third is because the westerlies have slowed down, the west to east movement of high and low pressure cells. The west to east movement of high and low pressure cells also slows down. The anticyclones and cyclones, next point, the anticyclones and cyclones moving eastwards are slow, and this phenomena is called as blocking. Basically, ये जो high और low pressure cells हैं, ये अब आगे move ही नहीं कर रहे हैं. They become very, very slow. It's called as blocking, right? In blocking conditions, the anticyclones and the warm, dry conditions can intensify, leading to heat waves and forest fires. Heat waves and forest fires in the mid latitudes. Okay? If I pardon and see if you want to ask me something here. I have a strong feeling they will ask questions around these current affair events now. और नहीं भी पूछेगा example में तो अब लिख के आना पक्का. Canadian heat waves, European heat waves, Canadian forest fires. We all knew about the forest fires of California. This time we have forest fires in parts of Canada. Warm conditions and these blocking cyclones. Can you all go through this once and ask me if you have a doubt? Blocking is of the cyclones. The anticyclones, cyclones will not move ahead. Yes, this is a high pressure. This is a low pressure and a high pressure, low pressure. I hope you know this. Meandering में Okay, इधर बनेगा हाई प्रेशर, यहाँ बनेगा लो प्रेशर, ये हाई प्रेशर, यह बनेगा लो प्रेशर। इसके वजह से नीचे जो है इसका ऑपोजिट, यहाँ लो प्रेशर हाई प्रेशर, लो प्रेशर हाई प्रेशर। ये लो प्रेशर आर द टेम्परेट साइक्लोन्स, द हाई प्रेशर्स आर द एंटी साइक्लोन्स। जब ये पूरा ही मूव नहीं कर रहा है तो ये भी नहीं मूव करेगा। अदरवाइज साइक्लोन्स, रिमेंबर, they move from west towards east, right? Okay, they move along the westerly tracks. जब ये मूव कम करेगा तो ये भी मूव कम करेगा। So this high pressure is trapped here now. Okay, sinking air, warm conditions, adiabatic warming, it now becomes a heat wave. Exactly. They are like stationary high pressure systems. Yes, correct. So in some places, they can bring cold air. In some places, they'll trap the warm air and cause your heat waves. Canada is seeing more of this. I mean, you can't imagine temperatures Canada may crossing 30-35 degrees centigrade. Okay, it's crazy temperature. They never thought it could happen. Okay, I'm moving on. The question was, I repeat the question. Okay, the question is Arctic amplification and the consequent changes in the strength and the position of the northern hemisphere jet stream will allow blocking events to become more frequent. The consequence of the polar vortex. Ho jayega answer? Done with diagrams? Okay. The next question. Changes in the fog frequency has implications for wide range of sectors, including coastal ecology, agriculture, and urban energy. Explain. अगर ये आपको एग्जाम में मिल जाएगा, आप लिखेंगे कैसे इसको? Can you make a quick jottings on? What will happen if the fog intensity increases? क्या होगा? And what will happen if the fogs will decrease? What will happen in agriculture? What will happen in coastal ecologies? And what will happen in urban energy? Can you all think through this and write down? सब में दो तीन point. All of you. There is global warming. There is climate change. It leads to fogs may changes. The fogs changes could be more fogs. The fogs changes could be less fogs. So what does this do to agriculture? What it does to coastal ecology? What it does to urban energy? Talk in terms of impact. Think this is a question asked to you in the exam conditions. आप prepare करके नहीं गए हैं, आप क्या लिखेंगे इसमें? कुछ बन रहा है आंसर आप लोगों का? Now say you have to use your geography, okay? Whatever you know. You know about Arctic fogs, right? Okay. So what will happen to Arctic fogs? बढ़ेगा, कमेगा? Will Arctic fogs be more or will Arctic fogs be less? Because of global warming, the Gulf Stream becomes powerful or weak? It becomes weak. So warm air carried to the Arctic regions क्या होगा? Warm water will become less. What about the temperature of the Arctic air mass क्या होगा? Will it be cold or will it be warmer? Warmer. Cold कैसे? Warm हो रहा है ना? Arctic warm हो रहा है तो air भी warm हो रहा है. Why is Arctic smog formed? Okay, when the cold Arctic air mass is moving over the warm Norwegian Sea, right? अब Norwegian Sea उतना warm रहा नहीं, Arctic air mass उतना ज़्यादा cold रहा नहीं. Will I have more fogs, less fogs? I have less fogs. See बात कर. If the Gulf Stream becomes less powerful, and and the currents from the polar areas become also less powerful, what will happen to Newfoundland fogs? Again reduce. देखो, I will write from whatever I know, right? मैंने अलग से पढ़ा तो नहीं है ना? So I'm applying my mind कि कहाँ fogs होता है, कहाँ fogs नहीं होता है. So fogs कहाँ होता है? Arctic fog है. Then we have this Newfoundland fogs. I have the winter fogs of the mid-latitude areas. I have fogs along the Peru coast. I have fogs in the continentality regions. ये आपके 4-5 fogs हैं. So tell me one by one क्या होता होगा? Arctic fogs will become less. The Newfoundland fogs will become also less. What about the urban fogs? क्या होगा वहां पर? More or less. Urban fogs will be more or less. So urban areas में smogs बढ़ेगा. For fogs, I also need a lot of moisture. Okay, they are becoming more drier. Okay, so the frequency of urban fogs will become less. But of course, smogs will become more because you have got more pollutant aerosols. And now you tell me one more thing. When will the fogs be more? When the water is warm, you'll have more fogs, or when the water is cool, we'll have less fogs. When will I have more fogs? Agar water warm ho gaya, okay, I'll have more evaporation. Okay, so I'll have more fogs here. Achha. What if the air remains warm, but पानी अभी गर्म नहीं हुआ है, उसमें क्या होगा? What if the air has become warm? Because water will take time to become warm. Air can become warm because of the winds from the coast. उसमें क्या होगा? Fogs will reduce. So what we're saying is the formation of fogs will now become more complex. The exact consequences are still not very well known. But in general, the fog patterns will change as following. Okay, all of you fine here? There will be seasonal variations. There will be locational variations. अच्छा बताओ, in the mid latitudes, when did we have more fogs? Winters or summers? Winters always, right? Land becomes cold winters. When the winters have become more intense but short duration, क्या होगा fogs को? You'll have less frequency of fogs, but जब होगा तब abundant fogs होगा. That's how you play with it, no? Okay. So आपको discussion है कि climate change is creating change in the frequency. Question देखो आप. Change in fog frequency have implications for wide range of sectors. Coastal ecology, agriculture, and urban energy. आप बताओ, if the fogs are less in the agriculture areas, it's good or bad? It's good or bad? Okay. Of course, both ठीक है, general हो गया. But if there is fogs, the area is moist, and moist is always good for the crops. जब dry heat होगा, the crops can burn. Okay, don't confuse fogs and frost. वो अलग चीज है. Frost is bad. Frost will lead to desiccation of the plants. So मर जाएंगे. But fog will keep the area moist. So in the coastal areas, जहाँ पर fogs कम है, it can impact crop productivity adversely. अगर fogs कम हो जाएगा, what do you think will happen to tourism? Increase or decrease? It will increase. Okay, because the coastal areas will have better visibility now. Have we got the point here? What happens to urban energy use? Okay, if you have got fogs, okay, and the fogs are erratic, winters may can have very dense fog for short amount of time. In those areas, in those conditions, your smog will increase. Your cars will slow down. You'll have more pollution. वो further बन जाएगा एक type का positive loop again. In the coastal areas, less fogs will imply better tourism. Because fogs you don't drive as much. Okay, fogs are not features of tropical areas. They are features of the temperate regions. So on one hand, it will be positive. In some areas, it will be negative. अब इसमें लिखना होगा as a proper answer. You have to write from whatever you know. आप छोड़ नहीं सकते इसको. Okay, you know fogs. Okay, Arctic fogs, Newfoundland fogs, coastal fogs, urban fogs, winter fogs. The deserts will become more and more drier. More dry deserts will have less mist in the deserts also. Okay, बस यही listing करके छोड़ देना है आपको. Write down, please. 1, 2, 3, 4. The first is, so what is the impact of changing global warming and impact on the fogs? The first is that Arctic fog frequency and intensity will reduce. Why? Because less powerful Gulf Stream and less intense Arctic air mass. Number 2, Newfoundland type of fogs will also reduce. Newfoundland type of fogs will also reduce. Again, less strong Gulf Stream, less intense polar currents. Both this will impact positively coastal navigation and maritime navigation. They'll impact positively coastal and maritime navigation. They will have a positive impact on coastal fishing. Positive impact on coastal fishing. Number 3, whatever. Reduced fogs because of global warming can impact agriculture adversely because of increased evapotranspiration, higher moisture needs, and therefore low productivity. Let me say down. Urban fogs in general will reduce, but smog events can increase. This can increase vehicular emissions. Next, in low water humidity and increased temperatures in tropical areas can lead to forest fires, particularly in the savanna belts. Next, in many parts of the world, fog water harvesting techniques are used for coastal communities. It helps drinking water and also in crop irrigation. Okay. I don't know if you have seen this or not. ऐसे they have nets like this. यहाँ पर लगा देते हैं, okay, and they allow for the fog to condense on this. ये पूरे जाली में. And then at some time of the day, they slight vibration ये पूरा पानी will fall down almost like a rainfall on the crops. Okay. And they can also use containers to collect water. It's called as fog water harvesting. Okay. They put nets over the crops. Okay. This has become one of techniques in many of the dry areas. Savannah में use करते हैं, coastal areas में use करते हैं, because the moisture जो भी हो kind of condenses here in the fogs. Okay. A very new technique and pretty popular. Savannah regions में, dry regions, because in the deserts also there is lot of mist night time. So if that can be trapped on the nets, and just before the early morning they vibrate this, the whole thing falls down as rain. It's a very reliable technique of agriculture. And the same fog becomes the base for evening fogs. The same moisture here. Dobara banega fogs, mist, again they trap, again it rains down. Okay. So this can be impacted. So you are relating fogs and climate change. Fine, all of you? So what I want is, ठीक है, आपको ये सब नहीं पता, but you can still write it with whatever you know. Okay, urban fogs, urban smogs, Arctic ones, Newfoundland fogs, and the coastal fogs. ये तो कर ही सकते हैं आप लोग. Okay, next. Now this question: weather systems arise from a thermodynamic instability of thermal wind shear associated with the pole equator temperature gradient. लिख लो इसको, I'll explain this to you. Now see, essentially you have two type of weather climate systems. One is for the tropical areas. The second is for the temperate mid latitude areas. In tropical areas, the weather here is largely thermal and it is wind controlled. Tropical areas, the weather hai, ye thermal controls. Okay, more heating, air is rising. Cold conditions, air is sinking. Offshore winds, onshore winds. Onshore winds, rainfall. Offshore winds are drier conditions. Okay. So this type of weather is okay to understand. In the mid latitudes, you have got three things operating. One is upper tropospheric winds are there. There are a dynamic, pressure conditions because of Earth's rotation and angular momentum. Okay. Plus, the conditions are also related to stability and instability because of air mass interactions. Okay. Whatever conditions of temperate regions we have, यही तीन है. Upper tropospheric winds, okay, the role of dynamic pressure conditions. This dynamic pressure also linked to upper tropospheric conditions. Okay, the jet streams are meandering. This is linked to the jet streams meandering, linked to Rossby waves. They are linked to Rossby waves. Okay, we call these as dynamic pressure. It changes and it's because of Earth's rotation. It dynamic ho gaya. And we also have, okay, the conditions linked to air masses. यही तीन को बोलते हैं, okay, your hydrodynamic instability. Okay, this is what is hydrodynamic instability. And thermal wind shear is the interlatitudinal temperature difference in the junctions of the vertical circulation cells. So some of you know this if you have been my student in some other older batches, but let me explain this agar nahi pata aapko. Now see, this is the poles, this is the equator, this is the poles. Okay, so we have the troposphere, lower height, higher height, lower height. We have rising air, we have sinking air. We have sinking air, we have rising air, and we have sinking air. Rising air, sinking air, sinking air. You know this, no problem. Okay. Now this is the Hadley cell. Ye bhi hai Hadley cell. This is the Ferrel cell. This is the polar cell. The Hadley cell is warmer in comparison to Ferrel cell, jo ki cooler hai. And this is warmer with respect to the very, very cold polar cell. Okay. So inke beech mein there is difference of temperature in this part between these two. Okay. This is warm, this is cold. यहाँ पर एक gradient बनता है. This is cold, this is very, very cold. यहाँ पर एक difference of temperature बनता है. This is again cold and very cold. यहाँ एक बनेगा difference of temperature. This is your subpolar areas and this is the subtropical areas. Subtropical areas, subpolar areas. Okay. So what is thermal wind shear is the difference of temperature between latitudes in between the circulation cells in the upper troposphere. So when the pressure gradient force is from equator towards the poles, this is high pressure, this is low pressure. So wind ऐसे चलनी चाहिए. Because of this difference of temperature here, this part, the pressure gradient force becomes all the more powerful. Because of difference of pressure here, the pressure force जो है यहाँ पर और powerful हो जाता है. Because of this, we have jet streams here. We have jet streams here. The jet streams are the consequence of this difference of pressure at the junctions of the vertical cells. Because you have jet streams, you ultimately will have, remember, Rossby waves. Because you have Rossby waves, you have the high and the low pressure cells. Because of that, you have the temperate cyclones and air masses interacting now. The question is about explain the weather of the mid-latitudes and how the mid-latitude weathers are not a regular thermal instability. Nahi hai. Okay. They are not because of the winds in general. They are because of the thermal wind shear and because of hydrodynamic instability. इस short में इसको बोलते हैं baroclinic conditions. Okay, so your syllabus has one topic called weather and climate. Okay, ये difference कैसे है tropical areas में, ये difference कैसा है mid latitudes. So what happens in mid latitudes is not same as what's happening in tropical areas. Is it okay, all of you here? Write down this point. लिखो आप. I'm just giving you 1 or 2 paragraphs. उसके बाद you're on. And once you know that this is nothing but air mass interaction, आप लिख लेंगे ना इसके बाद. The only problem was, what do the terms mean? Okay, write down now. The weather conditions of the mid-latitudes and the high latitudes are not governed by thermal conditions of the surface directly. The weather conditions cannot be explained by surface winds directly either. They can't be explained by the surface winds directly either. Next paragraph. The conditions are complex and explained better by upper tropospheric winds, jet streams, air mass interactions, and fronts. The conditions associated with these are hydrodynamic instability conditions of the mid-latitudes. Why do we say hydrodynamic? Why? Hydro is precipitation, rainfall, clouds. Dynamic, why? Because of Earth's rotation, because of the dynamic pressure of the upper tropospheric winds. So the weather or climate को मिला के बोलते हैं hydrodynamic conditions. That's all. Add a point here. The temperate cyclones and the patterns of weather because of temperate cyclones are good examples of hydrodynamic conditions. These conditions are also referred to as baroclinic conditions. अब समझा लेंगे आप, no problem now. Number 2. The next point, the thermal wind shear conditions are because of temperature difference conditions between the vertical circulation cells in the upper troposphere that create jet streams. So these are the vertical cells. ये vertical cells. इन दोनों के बीच में जो difference of temperature है, याद रखो, यहाँ पर ज्यादा नहीं होगा, यहाँ पर ज्यादा difference होगा. Because of this difference, यहाँ पर you have an additional pressure gradient and that creates jet streams. Okay, so at the margins of the vertical cells, इसको आप बना लीजिए. You can draw this again. Hadley cell, so here. Hadley cell, Ferrel cell, polar cell. Junction 1, junction 2. So vertical wind shear impacting okay, location 1 and location 2. Junction of Hadley and Ferrel and polar. Thermal wind shear conditions impacting location 1 and location 2. और ये कहाँ पर होता है? ये होता है upper troposphere. These create यहीं पर. ये जो conditions हैं. These create additional pressure gradient conditions and therefore the jet streams. और यही jet streams all the pressure patterns, whatever we know, and whatever rainfall. So what I expect is use these in your answers. अब आपको ये terms पता है, तो answer में use करो, ये diagrams बनाओ, how are they changing, what happens, and explain. Okay, so add karo that global warming and climate change impact the hydrodynamic instability conditions. Examples of which are polar vortex shift, mid-latitude blocking, slowing jet streams, and upper tropospheric westerlies, and more unpredictable weather of the mid-latitudes. Okay, the last question, this is a PYQ question, but it's a good question, so I thought you should know this again. So what is the impact of cryosphere in the global climate? Pattern hai. Some questions of GS get asked in your optional, and some optional wala gets asked in your GS. Okay? So be aware of this. Jab padhai karo, make sure you have seen both. Impact of cryosphere, okay, in your global climate. This was asked in the GS paper, if I'm not wrong. So my sense is optional paper. It's a very much an optional question. So cryosphere का मतलब क्या हुआ? Arctic ice, Antarctic ice, and the mountain ice, जो ice caps वाले हैं, ठीक है? So first list down, what does the cryosphere do? Then you're on, not a problem. तो अभी तो सारा वही तो पढ़ रहे हैं हम लोग, क्या पढ़ रहे हैं? Okay, the polar ice लिख लो आप. What is the role of the polar ice? Polar ice, high albedo, it sustains the pole, equator to poles, pressure gradient, drives the upper tropospheric winds. ठीक है? Melting of the polar ice, क्या होगा? Number one, the upper tropospheric westerlies will slow down. Number two, the polar vortex shifts polewards. Number three, the polar vortex shifts tropicwards. Number three, more extreme winters in the mid-latitudes in the winters. More extreme winters in the mid-latitudes. Number four will be blocking conditions, heat waves, dry conditions. Okay? You can handle this. This is the impact on the wind systems and climate. Second, how it impacts, how the melting cryosphere impacts the ocean circulations. So I believe you have heard about this, right? The meltwaters will reduce the salinity of the Norwegian Sea. So thermohaline currents will slow down. So the cryosphere maintains the thermohaline currents. अगर melt करेगा polar ice, the thermohaline currents slow down. So क्या बोलते हैं? It's also called as AMOC, Atlantic Meridional Ocean Circulation. It has slowed down now. Atlantic Meridional Ocean Circulation has slowed down. Why? Because weaker sinking of saline waters of North Atlantic. All of you know this phenomena? Heard about this? All good here? Just sun lo now that I'm telling you guys. So what's happening? This is the Gulf Stream. The Gulf Stream brings warm water and saline waters. Okay. और ऊपर से क्या आ रहा है? There is cold water here. This cold water is warm water. यहाँ पर क्या होगा? The water starts to freeze. When water freezes, क्या होगा? पानी इकट्ठा होकर salts अलग हो जाएगा. Yes. तो क्या बोलते हैं? The process of a brine rejection. Whenever you are freezing salt water, the water will freeze and the salts get removed. Water freezes and the salts get removed. And these salts become dense and they will sink down. Okay. So यहाँ पर the salts are sinking down. They sink down, they move along the floor towards Antarctic. But अगर ये पानी ठंडा नहीं रहेगा, तो ये freezing भी नहीं होगा. So in the northern Atlantic and Norwegian Sea में, the water is no longer as cold because Arctic Ocean se you are having now warm water coming out. Okay. So this brine rejection is becoming weak. The sinking becomes weak and the movement along the flow towards Antarctica becomes weak. This is called as the Atlantic Meridional, along the meridian hai. Meridional Ocean Circulation. AMOC bolte hain. The AMOC has slowed down. इसके अलग consequences होंगे. The cryosphere plays a very important in sustaining the AMOC circulations. Next one. Now, the cryosphere is also responsible for polar wala, for concentrating the stratospheric ODS to the poles. Have you wondered this? Why is the ozone hole bigger in the Antarctic region? Why? Okay, because very powerful winds coming from equator towards the poles. Those winds will carry with them the ODS substances, and the polar vortex will trap it, and they remain trapped in the polar vortex. Okay, so वहां पर ozone gets depleted. But imagine if the polar vortex becomes weak, तब क्या होगा? ODS fell. Therefore, the size of the ozone hole can increase. The cryosphere, okay, लिखो a point. The polar cryosphere traps the ODS, ozone depletion substances, traps the ODS within the polar vortex region. Okay, but with weakening polar vortex, the ODS substances can spread tropicwards. The ODS can spread tropicwards and therefore can lead to expansion of the ozone hole. Okay? Okay. Next, the role of cryosphere, the mountain wala hai. Uska teen important role hai. The mountain cryospheres, the mountain caps, ice caps. Okay. So they maintain the glaciers, and the glaciers feed the downstream rivers. The last time discuss हमने thoroughly किया है. The Asian water mountains, the Hindu Kush, Karakoram. याद आ रहा है आपको discuss किया हम लोगों ने? The very important water towers, the source of the rivers. Okay, cryosphere. Next, number 2. Okay, melting cryosphere, the mountains can lead to GLOF, lead to downstream floods. Third is the mountain cryosphere also maintains the mountain biodiversity of the higher regions. Okay. So this question was about the cryosphere on the global climate. ये part आप ignore कर सकते हो. Okay, global climate में आपका वही आएगा largely. Okay, polar vortex, the jet stream slowing down, the blocking phenomena. Okay, that's the main discussion of the cryosphere. So I have done climatology. You have the answers with you and this one.